the next thing I want to kind of shift gears, guys, is to think about, and this is called keyline design. So keyline design is P.A. Yeomans, again, accredited with this design theory. Most of it based on the concept of finding this key point. That's what we're going to try to find. So how can we see the key point? I want to be able to identify that. And how we can use that to control water in a broad acre landscape. So permaculture is great. Urban is taking off, people doing urban permaculture. And we need that because so many people are living in urban environments, but that may not change the world, okay? And we need to be able to have permaculture have systems to change broad acre farming. That's where our monoculture, waste, chemicalized agricultural systems, large scale animal production systems are on broad acres. So this is where we're going to be starting to look into how permaculturalists around the world are working on or combating the effect of these huge farms, and how you could go to a person and say, I can help you as a consultant, so that's what Darren does, and I can help you to change your farm to become more profitable, okay? And if you can't talk to them about more profit, they're probably not going to do it. So at this point, not only is permaculture more profitable per square meter for them, it's also more environmentally functional. So this is called keyline design, integrated applications for broad acre landscape development and maintenance, management. So that's from their website. But that's what we're going to look at, but I also want to introduce something called like the concept, well, what is permaculture design? Well, we could see permaculture design as an integrated broad acre biospheric design system, okay? If we want to use a big title. So how do I break that down and describe what does that mean? Well, we obviously have the permaculture design, that's our ethics and our principles, and that's what we've been talking about. But we need to look towards other disciplines. So we need to realize that permaculture grabs from and takes from some large disciplines. Who are they? So the next level from an introduction, I can introduce you permaculture, but there's these whole research institutes that focus on this one thing. And this whole research institute that focuses on this. Permaculture is kind of like a broad umbrella over these huge topics. So our principles and ethics go around. Yeomans, this is the symbol for Yeomans. So Yeomans basically focuses only on broad acre dam, swale, irrigation systems for farms, okay? That's their like specialty, and they're the best at it. And I highly recommend, I'll show you the website links later. Go check them out. Check out their YouTube videos on that, and you'll learn a lot. We also need to think about ZERI, so permaculture pulling from ZERI, which is called the Zero Energy Research Initiative, which basically means that we understand that there's kingdoms, and if we can cycle our biochemical cycles through the kingdoms, then we can derive economical or ecological yield without utilizing fossil fuel energy, for instance. And this is called the Holistic Management Institute. This is by a guy named Alan Savory that I'll introduce to you in a second. And he basically has an institute saying that we need to take our animal systems, especially in broad acre animal systems, and put them back into a more holistic management. Right now, they're not being managed in the concept of holistic. They're being managed in what we call factory farming or caged systems. They're not being allowed to do the functions that they would have done naturally. So if I say, where did a cow come from? A cow came from somewhere, right? Well, what would a cow do if it was wild? How does a wild cow act? Okay, and they still have wild cattle, even in the US. You can go to Florida, and they have areas where they're in the Everglades, and there's wild. What do they do, and how do they act? Why can't we manage them and more? And if we go to, obviously, Africa, we can see cattle more holistically managed. And we have the concept of carbon farming, or farming the soil to sequester carbon through farming activities that we're going to look into. So if we do all of those together, we may think of permaculture as an integrated, these are the integrated systems, broad acre, and then we're talking about biospheres, so biomes, so each location in the world is going to be slightly different design system. So how do I design for the biome that I live in, and how can I make it on a larger scale? So how do I take my food forest that I have here, which is like an acre, how do I think about making that into hundreds of acres or thousands of acres? How do we change the food systems, right? And we'll see that that kind of starts with Earthworks. So some key points, just summary of this, but I highly recommend you to go check it out in more detail at their sites. Keyline design is an integrated and profitable system of water harvesting and gravity irrigation, soil development and farm layout planning that was developed by P.A. Yeomans and Sons from the late 1940s in dryland Australia. Keyline design is a broadacre land design system used in permaculture design. The incorporation of permaculture design ethics and principles only increases the potential of keyline design as a technique and practice. Today, most common expressions of keyline design system is keyline topsoil development. So how do we build soil from the top up instead of the top down? Which is based on the use of ridge tine, non-inversive inversive subsoil plows and planned grazing. This is an incredibly fast system with 3 to 6 inches of topsoil development, quite common under most conditions, and over 12 inches where optimal. So within 1 to 3 years, they can make 12 inches of topsoil, where we can, in nature, that would take 10 to 12,000 years. So if we learn how nature does things, we can incredibly speed up the processes. So that's what they're looking at trying to do. Understand nature's conditionings. What does nature need to create soil? And if we help that, then we can make the soil faster. If we have a bigger topsoil is where the microorganisms live. So if we think about soil and dirt, dirt's in dirt. If I think about dirt, I'm talking about clay, gravel, sands, silts. There's nothing there. If I look under a microscope, nothing's going on. But soil's alive. So dirt is the home, soil is the living beings that create it. So that's what we call humic, or I have food, organic material, living things on the soil, which in order to have living things in the soil, I need living things on the soil to defecate, to have things living in the soil, and then I can create this. So if I can get 12 inches of topsoil, think about the biomass production. The trees are going to grow faster, the grass is going to grow faster, because there's more soil. So at this point, the key components of this design system are rapid topsoil development and maintenance. So how do I grow it, and how do I keep it from depleting? Rainwater harvesting and gravity irrigation systems. We need to harvest water so that we can keep that soil profile that deep. And integrated farm layout according to the topography. So I look at the topography, the water flows, and how I hold water in the landscape. So the key points of holistic management. Holistic management, HM, was developed by Zimbabwean Alan Savory in the late 1970s based on key insights he had made as an ecologist. Following his exile from Zimbabwe, Savory moved to the U.S. and further refined the techniques and practices of HM, culminating in the development of the Holistic Management International in Albuquerque, New Mexico. Currently, there's over 30 million hectares of land under HM across the world. Some of Savory's key insights are as follows, and including I operate HM at Raktamachat. Lots of permaculture places do. So that biodiversity is directly linked to human decision making. If I take on the ownership or stewardship role at Raktamachat, my decisions make the biodiversity that's here. How many frogs, how many lizards, how many fish, how many birds is up to me controlling the things that are functioning here, the habitat. If I don't take responsibility for that, that's how we end up getting into these monoculture situations where hardly any habitat is afforded and there's no biodiversity. Just this one plant, for instance, because of the targeting of profit. That by mimicking the high density stalking rates and constant movement of predator herds and grazing and browsing animals, we can improve the water and mineral cycles of environments under this regime of management, together with increasing the biodiversity of these systems and animal production. So if we can't provide habitat here for the animals to cycle the minerals through defecation, birds, lizards, to snakes, to frogs, to herbivores, to foxes, to all of the animals that would have lived within a biome, then our cycles break down, and over time we're exporting our minerals and the land will degrade. So we have to appreciate that. So he goes and he tries to talk to farmers to say, you know, you're the person in charge of your farm. And you're the person that creates, if it's increasing in biodiversity and mineral cycling, or you're the person really creating the systems that are decreasing it. And a lot of times this is focused on people that are doing herbivore management in confinement, which is still fences, right? And what they do is historically we take away all the predators. We killed the foxes, we killed the coyotes, we killed the wolves, we take away them. So then the herbivores who were conditioned to walk, they don't walk anymore, they just stand there. There's no predator. There's no predator-prey relationship. So a great video to watch to get an idea of what this is all about. It's called Wolves Make Rivers. So it's about Yellowstone, and Yellowstone was collapsing, and they said, what's going on? Basically all the herbivores were eating everything and killing everything. So they put back in the wolf pressures the herbivores move to less having pressure, and then all of a sudden the rivers cleaned up and the place just like went back to beauty when it was collapsing. And the only difference there was the predator-prey relationship. So everything is a yin and a yang and a relationship. Whether it's the soil relationship to the trees that we were discussing with the fungi, or these are all balances. When we take something out of balance, specifically the owner, which he's targeting, makes a decision to kill the predators, then the balance goes out and the system degrades. That by following a structured decision-making process measured against a predetermined holistic goal, people can make better informed decisions that will not compromise them personally, their enterprises, nor the environment or the society in which they live. So he goes and tries to talk to the farmers about, you have, not just personal, you may personally care about the environment, but the society cares about the environment. What are we doing and why are we doing it this way? And a lot of times the answer is, Grandpa did it that way. My daddy did it that way. Why don't I do it that way? And he says, well, maybe that's fine at that point, but what did your great-grandpa do? Oh, well, he came over on the boat. So he wasn't, it's not like some historical farming thing. We're only going back 3 generations, right? Or something like that. So we typically don't see it. So once you can talk to them, they say, okay, well, maybe it isn't that the only way to do it. So you try to educate them. So also watch, Alan Savory has a YouTube video where he discusses this. He was one of the head ecologists in Africa with the other ecologists there, and they decided that the herbivores were the problem in Africa, so they decided to kill all the elephants because it's the biggest herbivore. They shot like 80,000 elephants. And the safari all started to collapse. So then they had to go back in and do all these reintroductions because the herbivores create the grass systems. So without the animals, the grass is decided, and it started to turn into a desert. So it's just that balance of take away the animals and the plants die. Take away the plants and the animals die, and it turns into a desert. So carbon farming, a little bit more modern. So these are some older things that are happening, and it's this more culminating into this overriding things, especially with permaculture. Carbon farming as a term is fairly recent and has been popularized in response to the insights of people such as Alan Yeomans, Alan Savory, Professor Ratna Law, Dr. Christina Jones, and Alan Collins, among others. The development of systems to increase soil carbon through the action of soil biota has been led by the work of Dr. Elaine Ingram and her colleagues at the Soil Food Web. And if anyone has seen the Seeds of Permaculture movie where the 2 people are speaking about the soils and they're at the pile of corn stubble that we use for our compost, and they're talking about that. They're from the Soil Food Web. They came here to do a course, which I did with them, and how to, use a microscope to identify your soils and techniques, especially like compost tea, biofertilizers, in order to increase the soil microbial activity, which then builds soil and also sequesters carbon. So there's several techniques that have been developed that are designed specifically to increase soil carbon. So how can we sequester carbon in our soils as farmers? Holistic management, planned grazing, or management intensive grazing. So we can better utilize grazing techniques. If we're not doing that type of system, then we can use yeoman's keyline plows or plowing. So we aerate and soak more water into the soils. So more hydration of our soils increases soil carbon activity, because as we aerate and allow water, that you can have more, depth, and the carbon is locked into the affected microorganisms' bodies. So if they're living there, they're holding the carbon in the soil. The Soil Food Web designed compost tea applications. So we look at how to make compost tea and apply compost tea to increase the soil microbial levels. Applications of biochar, so how we can take our farm waste and convert it into carbon and then sequester or sink the carbon into our soils. And also added benefit, it increases the productivity as well as sequestering the carbon. And integrated farm planning using permaculture, keyline, and zeri, and holistic management inspired procedures and processes. So once we start to think about it in a more productive or management way of our biosphere that we're in, then we can start to make real changes to the amount of, say, microbial life that's stored within the soils, and that's directly proportional to the amount of carbon that's stored in their bodies, for instance, within the soil. So that brings us to the things about thinking about trees and also grasses and carbon. So here's a infographic that shows a forest. So this is a mature forest that has gone through succession, and it now has a mature climax tree that could be there for 50, 100, 200 years. And then next to it, maybe there's a prairie aspect. So here's a forest, and here's a clearing with grass. So the grasses are here, and the forest is here. During the life cycle of a tree, if we go to plant trees and we try to grow them up to sequester carbon versus grasses. So they go over on these websites, so I highly recommend you go to like soilfoodweb.com. They have lots of information, and also Elaine Ingram has lots and lots of YouTube videos where she describes soil science in a lot better concept than I can. I would say I learned a majority of the things that I know from her. So she's a true scientist, where I'm a teacher, different. So expenses, trees can be slow. It's expensive to plant them and slow to grow. So it could cost up to $2,000 a hectare to plant trees. But if we were to put in grasses, and they're talking about like these big grasses, like vetiver, big grasses, the big grasses can come in and they grow much faster and they're easier to apply. So it might only be $20 a hectare to change the grass regime than trying to put in trees. So we're going to see that what this means is not cut down trees and plant grass or not. It just means that if we're right now, let's say up against the 8 ball, we got to get something done. It's like a two-pronged approach. Get our forest replanted, but that's going to take a long time to make that difference, right? And in the shorter term, we have to be getting into better grass regimes, getting the grasses to grow, especially in places that we see desertification. On the edges where we're fighting that like desertification, it's really difficult to get trees to grow, but we could get the grasses established. Once we get the grasses established, then you can walk, say, the trees behind the grasses. So that's how you're going to like encroach on the desert. First get your grasses going, and then walk the trees. A great thing to look for on the internet is the Great Green Wall. So China has planted like so many trees trying to block the encroach of the Gobi Desert that it's actually seen from space. And the Great Green Wall. And another really great documentary is called Green Gold. And you can see how they've done things, and so it's just amazing to see. And that's real permaculture. And also it was really interesting to see that a government, and China being behind it, they're doing really big projects that would classify surely as permaculture on a nationalistic scale. So what does this come down to? This amazing carbon thing. How can we create carbon? How can we sequester carbon into our soils? So what does it take? We want to understand how soils build and sequester carbon. And what does it take to make soil to sequester carbon? Well, it takes basically 6 essential ingredients for soil formation to build more soil. So we need biologically available minerals. So if there's no minerals, we can't get any of our biochemical cycles going, and the plants and animals can't live because there's no minerals to cycle. We need air infiltration into the soil. If it's so compacted that air won't go in, nothing can live. These animals are aerobic and they breathe air. We need water. They like to live within damp environments. So we need the water to be able to infiltrate. Again, if it's so compacted that the water runs off, it won't grow soil. We need things living in the soil. That's our biologically effective microorganisms, bacteria, fungi. So we can inoculate those if they're not present. And we need living things on the soil, plants and animals. And we have to create the food cycle to feed to the microbes, so that they have to have something. That's our humic material, compost, for instance. And we need intermediate and patchy disturbance regimes, because if not, the soils will compact again, and we need to make sure that they stay decompacted, for instance. Similar to in our garden, if we keep watering, the soil will compact, and every so often, after 2 or 3 times that we grow our vegetables, we have to like break up the soil to get it re-aerated, for instance, and then that gets us a new growth cycle, and we can put in more humic material. So, another cool thing that's happening around the world, and this happened in 2005, and it's happened in other places, or 2008, sorry. We could wait for the international governments to do things for us, but it's probably going to be a long time, and they're never going to agree for, I don't think, any time soon. So certain places are saying, well, we got to do this like more so now. And if there's going to be like carbon taxes, why don't we do it on a local scale? If it's on a local scale, it's more controllable to us. I would rather a person that I can go talk to being in charge of what's going to happen with my money than some person that's like, I don't know, tens of thousands of miles away. I don't know who they are. I can't even talk to them. So this is in California, as they're a very proactive place. And it's called Sonoma County in California, called Marine and Sonoma County. And so they made a project. So they went and had voted on it. And it's called the Marine County Carbon Initiative, or Climate Initiative, or Carbon Project. So what they did is they went and it's very simple. So carbon taxes and sequestering carbon is very simple. It's not a lot of math. We're not talking about like huge things. It's not very complicated. So this is it, little spreadsheet, very simple. You can go to their website. They look at the population, what's the population of their county. At this point in time, they had 248,000 people living in that county. They looked at the average per capita release of carbon, the carbon footprint of a person in California in their county, that they calculated to be 23 tons of carbon per capita. So 23 tons times 248,000 people is what's being released by their living there. So that means that they had emissions in their county of 5,721,000 tons of carbon. So they went and they looked at, well, what kind of agricultural land do we have in our county? And they had 167,000 acres of agricultural land in that county. So they said, well, how much carbon would 1 acre need to sequester to offset the people living there's usage? So that would mean that 1 acre would need to offset 34.26 tons of carbon. Or for instance, if the farmer if you divided that, that's about 1.5 acres per person, right? So 1.5 acres per person, if it's sequestering carbon and we measure the carbon sequestering, we could offset the carbon for the people that are living there. So if we use carbon, so they made a local tax, like a consumption tax. So the now sales tax, they increased the sales tax by like 0.2%. Then that goes to the farmer. The farmer would then sequester carbon through either compost tea applications, biochar applications, or planting trees and or grass systems that they would not cut. So either way. You have many ways that you can calculate it, and then the inspectors are from the local government to go make sure that they're doing the program. So if they did that, they could sequester 8,581,000 tons, which is about 3 million more than they actually used, right? So then they have an economic multiplier factor that they said, well, if they actually do this, when you spend money, it actually makes people spend more money. So they used a multiplier factor in their economy of 2.5, which means that their economy would go because the people would be doing things. The total marine agricultural holdings, there's 276 families. So the average money that would go to each family from the other people to sequester carbon was around $77,000 per agricultural family on average, okay? And then they would do that work. So if we don't give the farmers some incentive to do the things, to a certain extent, just the increased agricultural productivity is not really enough. And so this is just a way of showing it. So I highly recommend, if you want to learn more, you can go to their websites. There are lots of YouTube videos also about their project. This is how they sold it, and they got their local populace as the local, what you might call grassroots movement. Let's take responsibility for our own locality, and we may not be able to change what California does, or we can't change what the United States government does or anything like that, but they could do it locally. So they said that the benefits of soil carbon credits that they did locally, they could increase the soil carbon that was stored in the carbon in their county. That would create less erosion of their lands. They would have an improved soil structure, right? And if they did that, that would have better water usage because of water retention due to biochar, for instance. That would have a reduced salinity. So the salinity of salts that were leaching into their water system would be reduced. That would increase their soil fertility of their county, which would increase the biodiversity of their county. That would have a healthier ecology, which would create healthier profits for their farmers and healthier farm families because of their healthier ecologies. And that would create stronger rural communities, which would be a benefit to the towns, cities and towns that were supporting the rural communities. And so that's how they got the people living in cities, the towns, to support having a consumption tax, if you will, in order to offset their carbon. So they're offsetting their carbon with that tax to their local farmers.